Python is not supposed to be this unreadable as this code here. It can actually be much more pleasant to the human eye, and in this lecture I'm going to transform this code into human readable code. But why didn't I do that from the beginning? Well, because I wanted to show you how Python works in the low level, so you understand the logic of Python. Now you are ready for the next step. So what I'm going to do is I'm going to open two files at the same time, and I'm going to change the code in the other file. So let me create a file. First, if you are in Thonny, go to Tools and Options and make sure to uncheck this Allow Only Single Thonny Instance option, then click OK. If you uncheck that, you can open more than one Thonny editor, and I can put one here on the right and the other here on the left. I'm going to close this files panel to have more space. I'm going to put this other comment as a separate comment here so that I can show all the text on the screen. And so this other Thonny instance opened in the same location, in the same folder, teaching folder. This is the complete path. And I'm going to go to New to create a new file. Control S or Command S to save that file, main2.py. Save it in the same folder as the previous file. I'm going to close this panel as well. And I'm going to copy the code from main1.py to main2.py. And I'm going to change the code in main2.py. So there's something in the jargon of programming called syntactic sugar. Syntactic sugar is part of the syntax to make some things easier to write and easier to read, some elements of the language. For example, you see here this object float 40.09 with quotes. Instead of having that, we can just write 40.09. And Python now knows that this is a float object. In fact, if you run the code, you'd get the same output. And if you check type latitude, you'll get that this is actually a float. So it's exactly the same object as this one in here. And Python knows to assign it a float type if it sees that it has this dot. So if it sees that it starts with a number and then it has this dot, then it knows it's a float. Same goes for here, 3.47. Then what else do we have here? Yeah, we have this int. So instead of int with double quotes and -1, we can just have -1. Now Python knows that is an integer because it starts with a number. It doesn't matter if it has a minus or it doesn't have any sign. So when it doesn't have a sign, it means it's a plus, it's a positive number. And if there is no dot after that, it means it's an integer. So you can check the type directly if you like. Type of -1, it's int. If you want to have it a float, but still want to keep the value of -1, you can do type -1.0, and you get a float. And then we have this method with underscores. Actually, these methods are not meant to be used like this. These methods are used internally by Python, and Python calls these methods when you do this. So this is now an operator. It's a multiplication operator in this case. It multiplies latitude, so the value of 40.09, with -1. And you don't need the brackets now. So remove the parentheses, execute. You can check the value of antipode latitude. You see that it's -40.09. So that was the last category of Python elements, operators. operators on the background, they call these special methods with underscores. So when you say latitude times, that times will get the underscore underscore mul underscore underscore method of a float, because latitude is a float. Python knows it's a float from here. So it gets the correct methods with that operator and it multiplies it with this other object. So this is still an object, that is also still an object, but it's different in an easier way. So I think you agree with me that this here is much more readable than this thing in here. But this is what's actually happening in reality on the background. Then we can move on. This LT thing was less or equal. So less or equal than 0. So same goes, this is also an operator and it calls that special method. And float 0, you can have 0, you can have 0.0, it doesn't matter. So type of 0.0, it's a float. But an integer would also be fine here and it's more readable than having 0.0. So I'll just keep it as an integer. And then add can be replaced by, well, you guessed it, plus. And this can be replaced by 180. Sub would be a minus. This would be 180 again. So the conditional is more readable now. We move on to this list antipodes, latitude antipodes, longitude. So list, you can remove all the parentheses there and there and use square brackets, just like that. Inside the square brackets you can write a series of objects that are contained in that list. So similarly to the other scenarios, Python knows that when you start with these square brackets, Python knows that you are creating a list object type, and then you just follow the correct syntax. So you put the first object, use a comma, use a space if you like, if you don't like, that's also fine. Use the other object if you want other objects, a comma, space, the other object if you have. In this case, we just wanted 2 objects in the list, and that's it. These square brackets, by the way, are delimiters, just like we had round parentheses. So round parentheses were delimiters, and this colon was a delimiter as well, comma was a delimiter. So things that are used to basically limit other things, to denote the borders of other elements of the language. Then we move on down here. My map equal to map round brackets location. So this looks like this thing in here, right? And you'd think that maybe there is a special syntax for this as well. But no, there's no special syntax for this. The reason is this map location is a third-party object. Remember that we actually installed Volume as a third-party package, and then we imported this map out of Volume. While all these have been designed, so these floats and integers, these are objects designed by the core Python developer team. They then develop this syntactic sugar thing that allows you to write some special syntax. For any other thing that is not a built-in feature, you have to follow the standard syntax of object creation. So you start with the name of the object type. It's a map in this case. In this other case, it was a float. And then you use parentheses. And inside the parentheses, you write the attribute or attributes, if there are more than one attribute, of the object. Then we go down here. So once we created the object, we access a save method of that object. So same goes here. Some methods, not all methods have these shortcuts like plus and less or equal. So this follows also the standard method access syntax. The object, the dot, the method, and then the arguments of the method. In this case is an object, a string object, which also have, since it's a built-in object, it has this special syntax where you don't have to write the name of the type, just use the quotes, don't forget the quotes for strings, and then the value of the string. So that is a string object type, whenever it starts with quotes. Yes, so in the case of this float, you actually used a string object to give the value, the attributes to the float object. So it was an object inside the other object. It was a string object inside the float object. We could have also written here str like that to be more low level, more inclusive of everything, but I didn't want to go that deeper. But basically the string is, so to say, the most low level object that it can give values to all other objects. And you don't have to write str for strings, as you can see, just use quotes. And then we have the print function, nothing to change here. This is how you call functions, so print, and you provide the attribute. It's important to note that even things like built-in objects have their own normal methods, which don't have this syntactic sugar, this shortcut. These methods are the ones that you see without underscores. For example, if you have a value of 1 or b 100, and then you access one of those methods, such as bit length, it doesn't take any arguments. It just gives you the bit length of that particular number. So it means that this integer is 7 bits in computer memory. What I was trying to show you is that the syntax is the same. So object.method. And that's about it. So this is actually the right way to program in Python. And this is the right way, I think, to teach Python, to make people understand. But now you know the secret, and from now on we will be using the right way to code in Python, which is this one here. So we'll be using operators and all the shortcuts that provide this very cool programming language called Python. I'll talk to you in the next videos. Thanks.